Hello students, this is the third part of system classification. Here we will be looking into two types of classification. First is time invariant and time varying system, and the second one is invertible and non-invertible systems. So first we will start with time invariant and time varying system. As it is shown in the diagram, we have a system in which the input signal is x of t and the output signal that we get from the system is y of t. We must remember that x of t results in y of t. A system is called time invariant if with time the input and the output of the system does not change. For example, suppose right now you are using a radio and you switch on the radio and you start hearing some station, for example, Radio Mangalam. After 1 hour, if you again switch on the radio and if you are going to get the signal reception of same quality, then we will call that the radio system is basically a time invariant system because the output is not varying with respect to time. If with respect to time the signal is varying, then the system is a time invariant system. So that is why the definition comes: a system is called as a time invariant system if its input output characteristics that does not change with time. And mathematically it can be explained by this equation, wherein you are having a signal x of t minus t, where capital T is the delay that you have applied. Then all that happens is the original signal also gets delayed. It does not change, but it only gets delayed. If such an equation is getting satisfied, then we will call the system to be a time invariant system. And if a system is not satisfying the above requirement, then it will be called as a time varying system. The definition is all okay, but what will happen if you are getting a question in examination where you are given the equation of system and asked to find out if the system is a time variant system or a time invariant system? Let us look at what is the method to be used there. Let x of t be the input, and let us consider that x of t minus t is the same input delayed by a time capital T. Then we have to find two outputs. The first output is y of t comma capital T, and the second output is y of t minus t. The difference between these two is, in the first case y of t comma capital T, it is the transform of the input signal which is delayed in time. So here the input is delayed in time and you are trying to find out what is the output. So you say that the output of the system when input is delayed. If you mathematically want to understand it, then y of t comma t is y of t when x of t is equal to the delayed x of t. Whereas what is y of t minus t? Y of t minus t is when you take the equation of y of t and you replace t with t minus capital T. That is the output delayed by capital T. What we can say from these two values is that if both of these are equal as it is shown here, then the system is time invariant, and if both of them are not equal, then the system is time variant. So mathematically this is how we will solve this question, wherein you are asked to find out if the system is time variant or invariant. Once again, you have to find y t comma t by putting the value of x of t as the delayed x of t, and y t minus t you calculate by just taking y of t and replacing all the t's with t minus capital T, and then trying to see if they are equal or they are not equal. If they are equal, then the system is time invariant, means the time with the time the system is not varying, otherwise it is varying. This was for the case of continuous time signal. Similarly, for discrete time signal also, you are having the same equation. The only difference is that instead of time, it is discrete values y of n comma k and y of n minus k. So this is the equation that you will use, and if both these values are equal, the system is termed as time invariant, otherwise it is termed as time variant. Determine if the system is time variant or time invariant. So as we have learned, we have to find out y of t comma capital T, which is the output of the system y of t when the input is the delayed input x of t minus capital T. Here, if we are going to substitute in the above equation, then we will get t square, and instead of x of t we will write x of t minus capital T. Whereas what is y of t minus capital T? It is output y of t when t is replaced with small t minus capital T, which is small t minus capital T square x of t minus capital T. Now as we can see here, the two values are not same, so we can finally say that since y of t comma capital T is not equal to y of t minus capital T, the system is time variant. That means it varies with time. Let us look at another. Y of t is equal to x of t square. Now we know that y of t is basically the transform when we give as the input x of t, and we know that its output is x of t square. Okay. Now if I try to calculate y of t comma capital T, that means I am trying to find out the output when the input is basically delayed. That means x of t is basically x of t minus t. In that case, what we are having is x of t square minus t. So what we have done is, whatever is the delay, the square of delay will not happen, only the square of time will happen and then the delay. Whereas if we are going to y of t minus capital T will be when you take the output, and in the output you substitute t is equal to t minus capital T. So the output is x of t square, where t we substitute as t minus t, the whole square, which again you can see is not same as the previous case. Thus we write, since y of t comma capital T is not equal to y of t minus t, the system is time variant. Y of n is going to give you x square of n minus 2. Now if I want to find y of, first thing that I will do is I will try to find y of n comma k, which we get by taking y of, that means by taking output at an input x of n equal to x of n minus k. That means we delay the input. So if we delay the input, what we will get is x square of n minus k minus 2. Okay. Next, if we are going to go for y of n minus k, that is the case when we are going to have y of n when n is equal to n minus k. In that case, I will just take the top part and then instead of n I will write n minus k minus 2, which is basically a square of n minus k minus 2, which we can see is basically same as the previous one. So I will write, since y of n comma k is equal to y of n minus k, the system is time invariant. Let us look at another problem. Next, let us look into the problem D. Y of n is equal to x n by 2. So as we have done previously, first what we will do is we will find out what is y of n comma k, which we know is to find out yn when the input is going to be x n, which is delayed. So n minus k. So all that is going to happen is we will get x n by 2 minus t. Whereas when we are going to calculate y n minus k, where basically we are going to take yn, and where all there is n, we will substitute it with n minus k. There we will get x of n minus t divided by the whole divided by 2, which is x of n by 2 minus t by 2. Hence we can say that the system is time variant. Therefore because y of n comma k is not equal to y of n minus k, system is time variant. So like this we can find out if systems are time variant or time invariant. Next we will look into the last type, that is the invertible and non-invertible system. For understanding what is an invertible system, look at this particular diagram. Here you can see that there is a system which has a impulse response of h1 of t, and there is an input x of t that is applied and you get an output y of t. That is explained in this particular sentence. Consider a continuous time system h1 of t which gives an output of y of t when input is x of t. Now if you are able to find another system h2 of t such that if we put y of t, that means if you take this output and you put it into another system which is h2 of t, such that you get an output which is x of t. That means you look at this particular image. So you are having h1 of t, wherein when you gave an input of x of t, you got an output y of t, and that y of t you gave to another system such that you got back the original x of t. Then this h2 of t will be called as the inverse system of h1 of t. And if any system has an inverse system, then that particular system is called as a invertible system. So here we can say is h1 of t is an invertible system because it has an inverse system which is h2 of t. Now based on example to example, you will have to see if there is an invertible system. So what is the condition? The condition is that for all times of t, not for just one or two times, for all times of t, x of t, if it is giving y of t, then y of t passing through an inverse system should give back x of t. In that case, there is an inverse system, then h1 of t will be called an invertible system. So with this, we can take it for discrete time. In discrete time, instead of t, it will be x of n, h1 of n, y of n. That's all the difference. There is nothing else. So the same thing can be written for a discrete time system. So with this, these are the 6 different system classifications that we have. And using this, we can try to define different systems. So we'll stop here. Thank you.